Hello, we're going to look at example 2 in your pre-calculus part 2 textbook. This is found in lesson 8.2 on page 820 and 821. Now, I've already worked example 1, or at least gone through the example with you to show you a couple of special cases. The example 1 was all about when you end up with no solution and what to look for that to happen. Okay, this is working the same way. You're using the Gaussian elimination method, and you're trying to get, of course, the main diagonals, of course, in the problem. You want those to become 1, and then you want everything underneath that to become 0. Now, back in lesson 8.1, I showed how to do the Gaussian method using this augmented matrix form. But as always, you're going to use the augmented matrix to turn the 3 equations into an augmented matrix, and then you're going to do whatever you need to do. Interchange the rows, multiply the rows, and add them together, again, so that you can get 1s down the what's called the main diagonal, and then you want 0s underneath. Now, in the process of doing that, I'm not going to go through every step of how they did that because I've done that back in lesson 8.1. But when they've done this particular problem and they've worked that out to start getting the 1 and then the 0 and then the 0, and then they're trying to, on this row, to get this to be a 1, and they're wanting this to become a 0. And so what they end up doing is adding row 2 and 3 together. And so they finally end up with this. Now, what is unique about this, and I know that the problem goes on further than this if you're really on the textbook, page 820 and 821, this goes a lot further, but I'm wanting to show you that really when you reach this point right here, that 0, 0, 0, and you just happen to get a 0 over here as well, what you're saying is 0x plus 0y plus 0z equals 0. What that translates into is that 0 equals 0. Now, because that statement right there is always true, okay, always true, because that statement is always true, then that means that you've run into a situation that you're going to have an infinite number of solutions. Because what you're really saying is here, it doesn't matter what I put in for x or for y or for z, because when they're multiplied by 0 here, any solution would make that true. So what that interprets us to mean is that when something is always true, like 0 equals 0, then you're going to get an infinite number of solutions. Okay? And again, this doesn't happen often, but it is one of the special cases as you're doing these augmented matrices and you're working those. Example 1 was about when you get no solution, and then here in example 2, this is about what happens or what to look for and expect for an infinite number of solutions. Okay? Now, the book goes on to go into a little more detail to solve, and then they take it all the way on further, but either way, the real truth is you can stop right here, because when you realize that this is always true, then you can come to the conclusion that you're going to have an infinite number of solutions. Okay? Hope this is helpful.